We welcome you to today's talk by Juan Moreno-Ternero. He's going to speak about fair international protocols for the abatement of greenhouse gas emissions. And I'm just going to introduce Juan briefly. This is a very brief introduction. So Juan Moreno is a professor at the Department of Economics at the University Pablo de Olavide in Seville, and an affiliate research fellow of the Seoul National University Center for Distributive Justice. He holds a PhD in economics from the University of Alicante and was a postdoctoral fellow at the Department of Political Science, Yale University, and at CORE in Louvain. His research interests include distributive justice, welfare economics, health economics, and political economy. He has published at least 40 papers on different topics in journals like Econometrica, Management Science, IER, Games and Economic Behavior, Journal of Health Economics. He currently serves as co-editors of the journals Mathematical Social Sciences and Journal of the Spanish Economic Association, as well as an associate editor for Economic Theory and Economic Theory Bulletin. And I hope you're all doing well, staying safe. And with that, I'm going to give the floor to Juan. Juan, usually, the speakers stop every 15-20 minutes to see if there are questions. People usually put questions in the chat. Either you can look them up, or Anirban and I and Malik can look them up and tell you. So it's up to you. So whenever you feel like stopping to take questions, just do that.
Okay. So first of all, thank you very much, Sudipta, for the invitation. And I'm truly pleased to be here. And thank you, everybody, for joining. It's my first time as a speaker of a webinar, so many things can go wrong with me taking control of this. So feel free to interrupt me as much as you want. I'll try to check on the chat, but maybe it might be easy that you just interrupt at some point, and I'll be totally fine with it, addressing questions as they come. So what I'm going to present is part of a research agenda in which I started working with my longtime co-author and friend Byung-Gi Ju from Seoul National University. And in this particular project, we brought on board two other Korean colleagues and co-authors. You will see why, because this paper happens to have an empirical side, and we needed someone to help with that based on our own records. A disclaimer: I already gave one saying that this was my first time as a speaker of a webinar. The second one is that, unfortunately, this paper is not about COVID-19, right? It seems like nowadays everybody's talking about it. Everybody has something to say. I unfortunately have nothing to say beyond a casual conversation like the one we had at the beginning. But this happens to be about one of those topics that happened to be the most important thing in the life before COVID-19, which was global warming and the reduction of greenhouse gas emissions, which by now looks like a very old problem, but hopefully it'll come back to the table at some point when life gets back to normal, quote unquote. Let me start. First of all, I'd like to see what, yes, okay, that works. So let me start simply introducing this by saying that it's been a long time concern of human beings addressing global commons, and more precisely, sharing the responsibility for using that. And I believe, I checked this before the talk, in the last 100 years, in the last century, there's been around 140 international agreements over environmental issues. Many of them have been extremely successful. And most of you, unless you're very young, will remember that back in the 80s, there was this huge concern about the ozone layer over the Antarctica. And there was this, what it came to be known as the Montreal Protocol, by which essentially all products that were contributing to damaging the ozone layer were essentially banned. And in a few years, we adjusted to that very efficiently. That was one example, but there are many others. There is some sort of a contrast with respect to this specific issue that we are addressing here, which is the issue of limiting these greenhouse gas emissions. There is some debate about it, but I would say that there is some almost universal agreement that the pattern is not good. There's that we have to do something. put it simply. But for several reasons, this international agreement is far from being reached. So there was this landmark Kyoto Protocol back in the 90s that seemed to be like a promising first step, setting actually targets for different countries. But it was clear very soon that it didn't work, in the sense at least as it was conceived. And not only that, it was also limited in time, and by the time the Kyoto Protocol was about to finish, there was no sensible alternative. There were different protocols and agreements, and the so-called Paris Agreement actually moved to a whole different situation in which countries were allowed to set their own individual targets, and everything was becoming voluntary. There was no enforcing whatsoever, and the trend seemed to be favoring the idea of reaching some minimalistic consensus, whatever it was, and meaningful, meaningless, sorry. But at the end of the day, things didn't materialize to the extent that when Donald Trump made it to the White House, it was even clearer that the pattern was in a dead end. So one might wonder what is actually the reason that is making this so complicated as opposed to some other agreements. Well, of course, when it comes to international agreements, you have to take into account that there are each country or each region involved in the process has different characteristics, and addressing these different characteristics, in this particular case, population, history, and future emissions seem to be the defining characteristics. Addressing these differential traits is obviously an issue. But when it comes to this specific problem, and much has been written about the possible reasons for the lack of success, you may agree that distributed justice plays a very important role to explain why things can break down apart or succeed. And this is more or less what we try to bring into the table for this specific question that I'm formalizing here. So how should we treat these differential characteristics that all the countries have in order to set a meaningful protocol to allocate these reduction targets? To motivate this, let me actually take you to a direct quote from one of the early steps towards an agreement along these lines that was set in the United Nations Framework Convention on Climate Change back in the early 90s. And I read directly from here because the quote is revealing to some extent. It says the following: the parties should protect the climate system for the benefit of present and future generations of humankind on the basis of equity and in accordance with their common but differentiated responsibilities and respective capabilities. Accordingly, the developed country parties should take the lead in combating climate change and the adverse effects thereof. Okay, so this is, from the very beginning, distributed justice was there in the spotlight, at the center. But I mean, it looks to me bizarre to be saying this in front of some of the people attending to this talk. But you know, there's a tradition of at least 4 decades in fair allocation, what is by now known as the fair allocation literature, dealing with various formulations of equity and also on the different responsibilities that can be taken into account to address problems with a concern for distributed justice, right? So the literature is sizable, if you want to use that word, and in particular, this literature has only been used the so-called axiomatic approach. This is by many of us is a very natural tool, but it's not the same in environmental economics. So in a sense, we're trying to bring in some of the tools we know in fair allocation to this specific issue. And hopefully this is what we'll do in this talk and what we try to do in this paper. In general, in environmental economics, you do have discussions on normative aspects, But these normative investigations, if you want, are generally framed onto the rules directly rather than onto the principles or the actions that end up singling out specific rules. Okay, so in a sense, we're trying to move the discussion to a lower level and talk about the principles rather than the rules. To illustrate what I'm saying about this environmental economics literature, let me tell you about a 20-year-old contribution by Neumeyer in ecological economics. This is a sort of influential view by now. And this was essentially an endorsement of what is dubbed equal per capita emissions with historical accountability. This was the general principle to address with this allocation of targets, of reduction targets for greenhouse gas emissions. The idea is, in a sense, grounded on theories of equality of opportunity. Roughly speaking, the idea is that you take an individual that has lived on Earth at some point, no matter whether he or she lived, no matter when he or she lived. But we assign to all these individuals an equal share of some common property, let's say. The property here being the global resource atmosphere, right? So if this is the starting point, the idea is that all individuals are equally entitled to have a share like that. Okay, so this is pretty much the principle underlying behind this idea of historical accountability. No matter whether this person lived today or lived 100 years ago, this person had the same right. And this is, of course, as soon as I introduce the model, I'll try to be formal about this, but this was pretty much the idea underlying behind this concept. But if you also dig a bit deeper, historical accountability was also underlying in a principle long embraced by the OECD countries, the so-called polluter pays principle. Again, this is bringing into the picture this idea of historical accountability. This is, roughly speaking, the philosophical quote-unquote idea, and I'll try to provide a very simple but formal model to address with these notions. Okay. So it seems to me that it makes more sense, given this audience, to move into the theoretical model right away, and then we can frame the discussion. But again, as I said before, please feel free to interrupt me as much as you want anytime. So the model is going to be very simple. We're going to be defining an emissions sharing problem as a combination of several factors. So on the one hand, we're going to have set of countries or regions, if you prefer. It's called that N. We're also going to have a targeted allowance of emissions, which is capital omega in this notation. And then there's going to be a matrix with an entry for each of these countries, right? Each entry is going to be a triple made of 3 aspects summarizing reality in a given country. These 3 are namely historical emissions. This is what I call HI, right? There's going to be what we call business as usual emissions. This is like the future, present and future trend of countries. And also there's going to be population. There's a caveat that I should make right away. For the time being, and actually, we don't have result on those lines because it's this benchmark setting. We're assuming this constant population across time. So we're going to assume that past, present, and future population is the same. That we know that that's unrealistic, and it might play a role in some of the results we have. But for the time being, we're going to keep it like that. So constant population. And then there's only one mathematical condition that you get imposed to these problems to make them an emission sharing problem. And it's this last one that I have over here, claiming that the aggregate historic and future emissions are above the target allowance. So in other words, we have to do something, knowing what we did in the past and using what we expect to do in the future, because if we keep business as usual, we'll go beyond limits. So that's the idea. Okay, mathematically speaking, I'll get back to that later. But for those of you who are familiar with the literature, this is some kind of generalized claims problem, right? So there's going to be a second dimension here that will be playing a role. Okay, that's pretty much the kind of problems that we're going to be addressing here. Now, once we formalize these problems, we obviously want to, quote unquote, solve them. So how do we do that? So we obtain allocations for each of these problems. An allocation being simply a vector indicating how much each country will be allowed to pollute. Okay. The only condition that we impose from the outset is that on aggregate, these countries will be exactly polluting the remaining of the targeted allowance once we take into account the historical emissions. Okay. Implicitly speaking, we're assuming that this is a positive amount, therefore that the targeted allowance is above what has been done in the past on aggregate, right? Otherwise, we don't even know how to start, okay? Anyhow, I'll get back to that later, because as you can see in the definition here, I make it explicit, we're not imposing that these amounts are non-negative. So in principle, we are allowing some of these amounts to be negative, to be interpreted as saying that this country went beyond limits already in the past consumption, in the past emission pattern, right? And then a negative amount in here would be interpreted as some sort of compensation with respect to the other countries, okay?
Excuse me, Juan,
yes,
which variables can be negative?
No,
which one exactly?
The allocation, X can be negative.
Not the others.
No, not the others, not the others.
Okay, okay,
yes.
all right.
Thank you, thank you. Sorry, any other question?
Yeah.
Yes.
Just to clarify, so for the time being, we can take the N and sigma, or omega, sorry.
Yes.
Fixed, given, so we know we are talking about a fixed set of countries and we are talking about a fixed target.
Okay,
so
that's a good
problem
question.
itself.
Yes, sorry. In the presentation, yes, it's going to be a fixed population setting. So we're going to keep N fixed. As to omega, you will see in a second that will be allowing for some sort of resource additivity there. So will indeed be allowed to be moving omega. I won't present them here, but we also have some other results in which you have a variable population setting. And then you can have results with actions formalizing this idea of non-manipulation, right? When you want your rules to prevent countries from merging or splitting, then you end up having some sort of generalized proportional rule. I'm not going to present these results in here, because indeed I'm going to be focusing on the fixed population setting for this specific. But for omega, it'll be a bit different. Let me explain that in a few minutes. Okay.
Okay. Thank
Anything
you.
else? You're welcome. So then we want to construct allocation rules. Allocation rules will just be functions or mappings, moving from the domain of problems so defined to the set of allocations. Okay. And for each problem, an allocation rule will be indicating an allocation belonging to this set. Okay, so that's the easiest part. Let me then move to the actions. As I said before, we're going to be exploring here the axiomatic approach. So rather than suggesting directly rules for this setting, I'm going to be presenting here actions. And let me start with two actions that are crucial and are polar of each other, and in a sense bringing here to this table some of the discussion that I introduced at the beginning. It's historical accountability versus history independence. Let me introduce them first, and then we can discuss about them if you want. Historical accountability is essentially saying that you will be holding countries accountable for what they did in the past, right? We do it in a very precise way. As follows. So we're going to say that when you solve a problem, you can do it in a two-step process. In the first step, you solve the problem assuming that the given country was not polluting anything in the past, right? So this was a purely clean country, let's say, right? Once you solve that hypothetical problem, you subtract from it the historical contribution of this country to the global pollution, let's say. Okay, this is historical accountability. As opposed to history independence, which says that you don't care essentially about history, right? So if you have two different problems in which a given country has the same business as usual pattern, namely future emission claim, let's say, and that the targeted allowance, namely the difference between what we are allowed to pollute and what we polluted together in the past is the same, then you don't care about these differences, right? So the solution will be the same to these two problems. So if you have two problems in which claims are the same and aggregate targeted allowance is also the same, then the solution should be the same. So you don't care whether there are differences in history patterns, right? That's what history independence is doing. So those will be the two, let's say, polar ethical positions. And what we're going to do is to combine them with basic criteria in the form of new axioms and see what the implications are in here. So the other.
Stop you.
Sorry, yes, of course.
One second. The first axiom, accountability, doesn't mean that FI is positive, negative, or anything.
No. Yes. Sorry, but what are you talking about? Negative here. So H.
No, I'm saying FI, the value of FI, which is.
Oh yes. Oh good. Yes. No. The only thing we're saying is that hypothetically, we assume this country didn't pollute anything at all. What would be the solution to that hypothetical problem? And once we address that, once we are able to estimate how much we would charge, quote unquote, this country with no record of past emissions, then we subtract the actual past emissions that this country had. No matter whether F is giving a negative or a positive amount, you're right in that sense. Yes.
Excuse me, you are assuming, you are always assuming that the sum of the HI is less than omega?
Yes.
Okay.
Yes.
It seems, I mean, tell me what I'm missing, but it seems that by these two axioms, you are completely cleaning the issue of historical contribution in one shot. I mean, okay, we pay those, and now we have a problem in which we have something to share according to consumption, and we can go to standard allocation rules.
Yes.
Is there?
Yes.
Okay.
No. I mean, you're fully right. We are simplifying the process in just two steps. You could argue that we could do this step by step, let's say, and that would require a dynamic framework, which we are not addressing in here. Which is not. It's much harder to. I mean, of course, you and I have actually been discussing about this dynamic rationing problems at some point. And it's extremely difficult to start with how to analyze that kind of problem. So yes. the plain answer to your question is that we don't know how to do it beyond this. So this is like a first step towards this goal, but you're fully right that this is far from being the answer to this general problem.
No. I mean, I'm just okay. Thank you.
You're welcome. So as I said, beyond these two bunch of three basic actions that we'll use as a package, let's say, which are described in this slide in here. The first one is what we call equal treatment of per capita equals. The idea here is to say that if you have two countries that on per capita grounds are equal, namely if you take historical emission per individual as a constant value, and if you take future emission per individual, that's also the same. If you happen to have these two countries that per capita are quote unquote identical in the past and in the future, then these two countries should get per capita the same. Okay, so that's the idea of equal treatment of per capita equals. That's one axiom. It's in a sense, there's some sort of impartiality requirement, right, on per capita terms. So population is obviously playing a role here from the very beginning. The second one is what we call irrelevance of excessive emissions. Namely, claiming too much, let's say, will be irrelevant. So we will not, beyond some levels, those extra units that you claim will be excluded from the problem, right? So formally speaking, what we're saying is that if you take the per capita future pollution of a country, right? And this is above the overall amount I'm allowed to distribute once we take into account historic emissions, right? That's the highest amount you'll be able to claim, quote unquote. Any additional claim will give you the same, right? The solution will be the same. The solution will not change for that individual.
Excuse me again.
Sure.
Aren't you comparing a ratio to an absolute quantity here? I mean, you're taking the claim divided by population.
Yes,
yes,
because I'm taking the per capita claim, let's say.
Oh, so each person in this country wants the whole, wow.
Yes, yes.
That's a hungry person.
Yes.
Okay.
yes, exactly. Yes.
All right. Okay.
Yes. You can think of countries with very low population but still polluting a lot, right? Highly polluted small petrodollar countries, for instance. Okay. Yes. And finally, the third one is a very standard notion of resource additivity. Namely, you can solve the problem directly, or you can solve the problem in 2 steps, right? When here you consider, when I talk about the 2 steps here, I talk about the overall amount taking into account the target allowance and the historic overall emission, right? So it's omega plus H, right? So you can do this in 2 steps. Maybe Hervé is thinking about an alternative to this additivity, which is this idea of composition. So if you solve the problem in 2 steps, so you may want to solve the first one, reallocate the situation, right, after the first step solution, and then deal with the second one. We conjecture that might allow us to do pretty much the same, but we're not, at this point, we're not able to give you an answer yet along those lines. But it seems that maybe this composition property might be playing a similar role to additivity in this setting. But for the time being, the results we have are with resource additivity as presented here. Okay. So those are the actions I'm going to introduce. I won't have more actions than those, and I can already present as a matter of fact, you know, I could give you, I don't have it like this in the slides, but I could give you a preliminary lemma telling you what the implications of these 3 actions together are. In particular, these 3 actions together tell us how to solve the problem in which the amount to allocate is 0, right? So you can easily do it in here. But I don't, as I said, I don't present the result like that, but it's crucial to show the first theorem and the second theorem that I'm going to present right away. So what I have in here now is what is the effect of combining these 3 actions, this package of basic actions that I've just presented before, together with one of the 2 historic quote-unquote actions that I presented in the previous slide. So what do we have when we add to these 3 historical accountability? And we have precisely what we call historical equal per capita rule, which we believe is a precise formalization of what Neumayer was suggesting in his ecological economics contribution 20 years ago. So the historical equal per capita rule does the following. You take the overall amount you can allocate, and you allocate it proportionally according to population, right? Oh, sorry. Okay, so you take per capita an equal amount for everybody. And that would be the first member, right? The first element of this sum. The second element is, I mean, of course, this can be written in an alternative way, and I can say it right away, but I wanted to present it like this first. The second element is precisely, look what you have in here. So you have population times this difference here. This is the ratio. This is per capita terms, the historic emission of this country, right? Compared to some sort of average historic emission of all countries, right? So you take the overall emission, historic emission, and divide by overall population. So in a sense, you are comparing the individual performance, historic performance, with respect to average performance, historically speaking. So if you were below or if you were above, will allow you to be below or above this, say, equal per capita contribution, right? I mean, if you play with the algebra, it's straightforward to see that, of course, you would cancel, so Pi divided by aggregate P, right, would cancel with the first element here, and at the end of the day, you would just have this minus HI, right? So you would just be subtracting the historic contribution, right, to the quote-unquote proportional allocation of the targeted allowance you have. This is the rule characterized by these actions, or to put it differently, the rule that Neumayer was proposing, this historical equal per capita rule, can be characterized by this combination of actions, these three basic actions and this crucial idea of historical accountability. And as I said, the proof, I'm not going to show the proof here, but the proof is sort of intuitive in the sense that these three actions will tell us how to solve problems with zero amounts to allocate, and historical accountability will allow you to disentangle the solution to the starting problem into two problems. One in which the amount to divide is zero, and another in which the historic contribution is zero, right? And so once you've solved the first one with the other three actions, historical accountability will tell you how to solve the other, right? With zero emissions. And that's pretty much the way in which the proof works. Now, if instead of historical accountability, you have the polar historical independence, then you would have a characterization of the equal per capita rule, right? Which, as opposed to the previous one, only misses this correction here, this second element that we were correcting. Remember what I said before about this sort of comparison between individual and collective performance or average performance. That disappears here, and you just take the per capita population and multiply that by the overall allowance here. And again, it's crucial here. The proof is crucially relying on the fact that the last three actions, the last equal treatment of per capita equals, irrelevance of excessive emissions and resource additivity, are telling us how to solve a situation with zero history of emissions. But because of history independence, that's precisely the solution of the original problem, right? So that's pretty much the proof. Okay, so the two results are tied in the sense that no axioms are all axioms are essential. So you can always provide a counterexample of a rule that exists satisfying three, but not the fourth axiom, right? So the results are tied, and that happens for both of them. I can provide some examples later. But before doing that, let me get into the numbers applying this. So it turns out that we can use this very basic framework, theoretically speaking, that I presented before, to give some numbers, right? And the application here is considering these four regions. Actually, the regions were so determined by the OECD. It was actually the United Nations. The United Nations was considering these four groups that I have it in different colors. So the green one is the countries that belong to the OECD in year 1990. There was the Asia region, including mostly India and China, of course. There was the Africa and South America region. There's the yellow one. And finally, the red one, it's essentially Russia. I believe the precise definition was something like countries under reform, whatever that meant, right? Back in the 90s, the Soviet Union had just collapsed. So that was the four groups, and it makes sense to keep them for these illustration purposes. Okay, so now we set different thresholds for targeted allowances. And here, this paper it's a bit old by now. It's 2009. This is paper in Science with three target emissions from 2000 to 2050, right, at 3 different levels, 1440, 1000, and 745. I'll be concentrating on the last one, right, because those correspond to these probabilities of exceeding this 2-degree increase in global temperature, right, with respect to pre-industrial levels. Okay, so I'm going to set those, and this is the table I have. Here in this table, I'm using the 3 thresholds here for each of the 3 groups, but and then I have these 4 groups. Okay, sorry, before going that, and I have several columns. The first 2 columns are the 2 rules that I characterized in the previous results. And the next columns are essentially using these well-known rules in the literature on bankruptcy or claims problems, where you dismiss whatsoever information over historic emissions, and you just deal with this sort of bankruptcy problem in which you take into account the claims each country have about future emissions when business as usual, and the amount that you're allowed to have them pollute, right? So in that sense, there's no negative amounts whatsoever, but we just put him for the sake of comparison, because we believe that those rules are lacking this issue of addressing history, and therefore we believe they are not sufficiently accurate for this kind of problem, right? Now, if you look at the first 2 columns, right, that's pretty much what you would expect from the results we were obtaining here. And what can you see? Well, obviously, in the first column, right, you observe that Asia, being the largest populated region by far, is getting a higher number, right? That's not surprising. But the second one, and I'll be more precise in this next pictures when I move to the country level rather than to the region level, the interesting thing is that when you correct for historic emissions, right, and using the first of the rules we characterize, you obviously punish more the OECD countries for 2 reasons. In terms of population, compared to Asia, for instance, this is a much less populated region. And obviously in terms of historic emissions, those were the countries historically polluting more, right? And so you have these negative amounts, right? But let me move into the country level, because there'll be some not surprising but interesting issues to discuss. I'm now going to concentrate on the 3rd level, right? The lowest level of pollution allowed. And here I have a bunch of countries. So France, Germany, Italy, Spain, UK, Canada, US, Japan, Korea, China, and India. I have 3 columns now. The first 2 are the 2 rules that I was characterizing in the previous results. The third one is the proportional rule, which is very similar to the Kyoto Protocol allocation that was recommended in the first place. It's not exactly like that, but it's very similar. It's what is in environmental economics called grandfathering rule, pretty much. So what do we have here? So the table will remain the same on the left side of the screen. On the right side, I will be representing each of the columns. So here I'm representing the first column, EPC, equal per capita rule. And what do you see? Well, obviously you see that China and India, being the most populated countries by far, will be getting a higher allowance here. So the target will be much higher for both China and India. It will be reasonably high for the US too. The US has a large population as well, right? But to a lower level, obviously, with respect to India or China. Now, if we move to the historical rule, then Donald Trump would love that, right? Because you see that how the US goes dramatically down. It happens to be the case with Germany too, and the UK. Of course, historically, they also polluted to a large level. So did France, right? In the case of Italy, it's pretty much even. It's -1, as you can see here. Spain is almost 3. Sorry. But look at China and India, right? So this is obviously rewarding them more. Historical emissions were nothing there compared to the other countries, and that's how you would move the situation from one case to the other, right? In the case of Korea here, Korea is not as much populated, for instance, as obviously as the US or India or China, right? But Korea didn't pollute that much in the past. So this amazing development of Korea happened in the last decades, right? So in that sense, it's not being punished historically, but it's not being that much rewarded because of the population, right? If to finish with the comparison, we move to the proportional case, which is pretty much what the Kyoto Protocol was saying. Then again, here the US is benefiting largely with respect to the previous one, not as much as China. And what happens with India here with respect to China? Well, India is not the business as usual. The projection of future emissions for India is nothing compared to projection is in China or the US, right? That's what why this example is in a sense putting India in a worse position as opposed to the previous ones. Okay, so in this case, this Kyoto Protocol like allocation is rewarding countries with high claims, countries with projections of huge future emissions, right? And so in that sense, we have here three alternative scenarios that pretty much establish what the situation is going to be. Okay. Well, that's for the empirical application. Let me simply conclude with what I said before. This was the missing point. Although I mentioned this in passing, the results were tied. So, for instance, if we get rid of equal treatment of per capita equals, you can have something as easy as this. You have an equal sharing of the overall amount and subtract from it the historical emission. This historical equal split, if you want, or historical equal sharing rule, is a rule satisfying all the actions except for equal treatment of per capita equals. If instead you have this historical proportional rule, when you allocate this allowance proportionally, not according to population, but according to claims, right, in terms of proportional claims, and then adjust according to the historic component, you will satisfy all the actions except for relevance of excessive emissions. Okay, so that's another axiom. If it's resource additivity, you can come up with this sort of pathological rule, right, in which you take the minimum of these two levels and sort of make it proportional to population, right, and then subtract from it historical emission that satisfies everything except for resource additivity. And of course, the fourth one, the one in which we don't have historical accountability, is precisely the other rule that I got address. You can also modify these examples easily to come up with counterexamples for the second theorem, right? To show that the actions in the second theorem are also crucial to be used for the characterization. Okay. Now let me I'll say a few more things connected to the literature, but and I obviously be more than happy to address the questions that might be pending there. I wasn't paying that much attention to the chat. Again, I apologize for my lack of experience in this. So let me simply tell you that the message that we wanted to convey with this part of the research agenda that I presented here is that you can consider a stylized model of setting greenhouse gas reduction targets and formalize normative principles with wide appeal as actions of rules for this setting. And in particular, the combination of some of these actions will characterize two focal rules. One of them is actually, so one of the results we provide is like a formal endorsement or complementary endorsement of this idea of historical accountability that Neumayer proposed in the first place. But we also propose a sort of dual result, which is providing support, normative support for the alternative history-independent rule to this equal per capita sharing rule. Okay, so that was the result. Let me also mention, and to conclude, that as I said before, this could be seen as a sort of extension of the well-known claims problem or bankruptcy problem. So you may be aware that William Thompson has been writing most of his life about many problems of unfairness, but in particular this model on bankruptcy problem, to which Hervé has also famously contributed himself. But William has been carefully developing this book, which came out a few months ago as an Econometric Society monograph. It's, I believe, Hervé might know better than me, it's a 500 long book or something like that, dealing with this very simple problem. This problem which is simply, pointing a line, as he likes to say, right? So the bankruptcy problem that was initially formalized by O'Neill is an extremely simple model, but extremely powerful and fruitful in many ways. Now, the problem is simply dealing with this issue of how to divide when there isn't enough. So individuals have claims over an insufficient endowment. So in that sense, we're having the same here. So you could say that claims are future emission paths are individual claims in that setting, and the allowance is the amount we have to allocate. But the important thing is we bring to the picture this additional aspect of historical emissions. It's not only about what we're consuming now, but what we're producing in the past before. So it turns out that for the last year, there's been some efforts, and I was working myself a little bit on it, on generalizing this rationing or bankruptcy problems to the case in which you have these two dimensions. Okay? The motivation for this is what is called in the literature now, rationing in the presence of baselines, or baseline rationing. The motivation for this came out with a sort of environmental problem too, that happened about 10 years ago. Back then, it looks like prehistoric times, but there was a time in which the governor of California was Terminator, right? So Arnold Schwarzenegger was the governor of California. And he came up with this very interesting, so there was this drought in California, and there was this water rationing, right? So they had to do something about it. And they came up with some sort of interesting protocol by which individuals were asked to reduce consumption by a given percentage. I don't remember if it was 20 or 25%, but it was a complex scheme in which it was not only the amount individuals were supposed to be consuming that year, but also the amounts individuals were consuming in previous years, right? Which also sets the ground for, connected to what I said to one of our best questions before about this idea of dynamic rationing, right? Yeah, we have to allocate water this year, right? But we'll have to allocate water next year too, right? And then we would like to take into account how much you need of water this year, but also how much you use of water last year. Why? Because we may want to punish overconsumption, for instance. We may want to reward that you were, capping your contribution, things like that. Think of, for instance, there's going to be a lot of discussion now with this sort of rescue efforts, at least at the European Union level. I don't know how it's going to work somewhere else, but the European Union is setting these funds to countries that have been severely hit by this pandemic situation, especially countries in the south of Europe as usual. And now, how are we going to, deal with this once the allocation takes place, right? How are we going to return this money? Even at the national level, the national government in Spain announced a few weeks ago that they will be allocating 16 billion euros among regions to sort of help for the extra efforts that took place in the last few months. It is controversy now because it's not clear the way in which they're going to do it. Some regions claim that it should be mostly about populations. The central government claims that it's mostly going to be about health expenditures and also education costs. And of course, the Catalans have their own agenda, and that will play a role there too. Apparently, Hervé might laugh because Hervé knows a little bit about this, but the central government is announcing 16 billions, and the Catalans want to have 15 themselves. So apparently, leave 1 billion for the rest of the country, and 15. This kind of issue. But again, all I was trying to say is that this kind of problems happen on a dynamic framework. So every year there's a budget from the central government allocated among regions, right? And of course, when it comes to allocate this budget, you might want to take into account what they are asking for, assuming that these claims are in good faith. But at the same time, you may want to take into account what you did in previous years, right? So a naive way of approaching these dynamic problems is by collapsing periods in two. Let's say you have a past period, quote unquote, encompassing everything, and you have the present period. This amalgam of past consumption, let's say, is what we call baselines here. So suppose that is summarized as a vector, right? It's a past consumption, and you have present consumption. How do you want to take this into account? So this is pretty much what, mathematically speaking, is underlying behind the results I was presenting before, right? So we have these historic emissions, and we have these present or future emissions, right? And we want to take them both into account. We did it here in a very peculiar way, in the sense that we were solving the present and adjusting with the past, right? This two-step process, but Hervé was indicating that was just one way, and there could be other ways. And in a sense, that's linking to this idea, to this theory of rationing with baselines that I'm formalizing here. But that would be beyond the scope of this, and I don't want to extend myself further. So I believe I didn't exhaust the time, but I don't want to be one of those speakers going beyond, because some of you might be tired. So I prefer to stop in here, and obviously I'll be addressing all the questions that you may have, and I'll be happy to do so. And thank you for listening so far. Thank you.
So yeah, take questions. Yeah. And yep, free to take questions. So if people have questions, please go ahead. We still have. Yes, Hervé, please.
Hervé.
Okay. Thank you. Yeah, in rationing models, we think of the model as being primarily one in which all parameters are objective. It's something we can measure. There is no discussion about that. Here you have the historical component, which is a very controversial one, right, to say the least. First, it's very hard to measure, and then there is the whole issue of, the Industrial Revolution started in the UK and the whole world benefited, so that kind of pollution is actually shared and so forth. So I think, to me, the fact that you have this axiomatization of the two extremes is nice, but it would be also really useful to have an approach which leaves that, the importance that you place on the HI going from 0 to 1. We do have on the strict axiomatic side, in several instances, you characterize a family of rules which goes from one to the other, and therefore leaves this parameter open. In what way you do, axiom one, axiom or the other. And then, of course, you could also go one step further and think of it as a political issue, because if those kind of reduction agreement ever become reality, some hard agreement on force and so forth, there will be a real complicated political process. But here it's not, maybe it's not so complicated because it's one-dimensional and countries have a position. So, this goes outside the rationing model, but maybe there is something there. To try to combine both the, solid axiomatic rationing with some kind of political economy in the background. But just to stay in the axiomatic context, I think it would be neat to have some version in which you don't have the two extreme axiom, but you have, I don't know exactly what, that's in between, and that takes you from one to the other. That would be really nice.
That's fascinating as usual, Hervé, with all your comments. So all I can say is that we have thought about partially about some of those. In terms of the compromise, one natural thing that we could think of is not as axioms. I'll take to the axioms in a second, but as rules. You could take some sort of convex combination of the two rules that I presented, quote unquote. Now, how do you provide normative support for that? right? So one possibility would be, in taking you back to the first question you did, this historical accountability was extreme in the sense you were saying, how do we solve it with zero past historic emissions and get rid of the rest? What if we have something in between, saying like, there was some in the past, and how do we do now? So it's sort of connected to this idea of composition that I mentioned in passing as well, right? So what if we take into account, let's say, would you polluted up to the Industrial Revolution or up to the 20th century? And what do you do after that? So maybe you can parameterize this axiom, quote unquote, and come up with a compromise, having these two other rules in the limits. That's my conjecture. I don't know. So you have this very nice result from the late 80s in which you have this family. It's actually more general than the rationing problem because you allow for negative amounts too, but there was this combination between proportional and equal sharing. And there was this alpha, there was some sort of complex combination. So I'm guessing that kind of family could arise in here, but to be honest, we haven't brought results along those lines yet, but that's very, very interesting. As for the second one, the political issue, fully agree. I mean, I fully agree. In terms of how do we capture this in the model, I guess there could be some sort of implementation part, right? It's not only about the rule, but also about how do you implement this. There could be, I don't know, some sort of bargaining protocol among countries, in the sense that, and the bargaining power of these different countries would be somehow determined by either past emissions or past allowances or things like that. I mean, there's gotta be something, to be honest, in the environmental economics literature dealing with how these environmental agreements are reached at the international level. Some sort of bargaining protocols. But to be honest, I don't know. You know, I haven't explored the literature that much, but it's fascinating. So it'll definitely be something to look at. So thank you very much.
Other questions? Right.
Yeah, so no one else?
So
Yes, hi, Sudiptoda. Hello.
yeah.
Hello?
Yeah, I had a quick question. So I understand that an axiomatic approach has been used to solve an allocation problem. It would be actually great if you could show that the resulting allocation from the axiomatic approach belongs to the core, because then there is no incentive to break away from the coalition on agreement. That partly would account for, you know, the political economy, the political economy aspects that you guys were talking about. Thank you.
Right. Yes, this in a sense is connected to this political aspect.
Yeah.
Now, in terms of rationing, the core is in the standard rationing model that we were discussing before. The core doesn't impose many restrictions, so it's a very weak concept. Now, in this more general setting, I wouldn't know, but I have the impression that it could not be very. I mean, of course, it all depends on how you define the associated bargaining problem or cooperative environment to this setting in terms of the historic accounts. But if you take just, you forget about historic emissions and you just concentrate on future emissions and the target allowance, namely the rationing, standard rationing model, the core is a very minimal requirement, and all well-known rules satisfy the core constraints. But I'll look into that for this specific setting. Thank you.
So Juan, I just have a very short question.
Sure.
So I was just wondering, so this equal per capita, the rule, so the one that we were talking about.
Yes.
Sorry. So there, that equal treatment of per capita equals.
Yes.
So, I mean, let's say, I mean, when we talk about emissions, so how, I mean, it's not per se an allocation issue, but how fair it is to compare between two equally emitting country. I mean, for example, how fair it is that we put the load on the whole population, rather than I mean, we are looking at the population as a homogeneous entity. So I mean, from the fairness perspective, if we look at it, how do you think that comes out?
Right. So that's very interesting, and it's very natural too. I mean, of course, at the end of the day, we're talking about countries because those are the entities we're dealing with. But at the same time, countries are different in terms of population. So it would be unfair to say because of these two being two countries, they will pay the same, provided one is China and the other is Luxembourg, let's say, right? So that doesn't seem right. So in a sense, you're putting into the spotlight this idea I mentioned at the beginning, that each individual has an equal right, let's say, right? No matter whether this individual lives here or there. But you're fully right in the sense that at the end of the day, this is not as clear, right? Because individuals come as groups, right? I'd say that normatively speaking, this idea of per capita makes sense because of what I try to indicate, that individuals have the right. But at the end of the day, you implement these rights via countries. Of course. You could avoid these per capita considerations and come up with rules talking about countries rather than individuals, right?
Yeah.
I'd say that you would easily have an easy situation like the ones I presented before. Large countries would be much more benefited from this treatment than small, and a small country would be severely punished. So I'd say that these per capita considerations make some sense here. But the two issues are relevant, definitely, and you have to be aware that you are accounting for both here. That's a tricky thing. That's a tricky thing. I fully agree. Yes.
Thanks. So anybody else wants to pitch in here? If not, then thanks, Juan. Thanks a lot.
Thank you. Thank you very much. It's been my pleasure.
Yeah, it was a really interesting talk, and there's a new endeavor from the GamesNet team, and we expect you to be in the audience.
I will.
Yeah.
Yes. Thank you very much. Keep me posted. I'll be more than pleased to be.
Definitely we'll keep you posted. And for all our other viewers, will be our 6th webinar will be on 23rd, and Hervé Moulin will be talking. We'll send you the invitation maybe around 5-6 days before the talk, and of course a reminder a day before, so you will get the emails. So yeah, till then, bye bye.
Thank you.